This week we will take a small dive into machine learning and how it can be done in Python using the scikit-learn package. We will not talk about the theoretical background behind different machine learning algorithms, but we will give you a quick overview of what machine learning is about. And then afterwards we will cover two of the subfields of machine learning, namely supervised learning and unsupervised learning. So what are these subfields and what even is machine learning? Previously, when we analyzed our data using, for example, pandas, we did a rather surface level analysis. So for example, finding the max value in a certain column, or we averaged based on some grouping. Of course, we can also do more advanced stuff in pandas, but the analysis will not touch the deeper structure that our data might have. And so this is what machine learning is for. Here we're trying to find or model the underlying structure of our data. And clustering can be used to group data points based on their features. So we can see here, for example, a lot of data points, and by grouping them based on their features, we can recognize some clusters. And this can then tell us something about the underlying structure of our data. So here it says customer segmentation. So we can imagine that a data point describes one customer, and maybe this description consists of 100 values, having details about stuff like age, origin, income, and so on. And then by clustering all these data points, we can project them into this 2D surface, where we try to conserve the distance between the data points. And then instead of looking at a 100-dimensional space, where it would be impossible to find any structure, we have this nice plane here, where we can now tell that there are 3 groups of customers that are different to each other, but similar to themselves. From the supervised learning side, we can check out classification. More specifically, image classification. If you think about how to write code that could recognize a cat, you might think in the first moment that that is not too hard. For example, we could check the image for a certain color, and also if there's some pointy things that could resemble the ears. But if you think deeper about what really is a cat, you will see that this is really not a trivial problem. Because for example, what if the ears are out of the frame, or the cat is slightly rotated, sitting, or lying, and also the color of the cat could be almost anything. So our manual analysis does not work. So what we do again is we rely on machine learning. And the difference now to unsupervised learning is that when we model our data, the data is split into feature and targets. So in this case here, the feature is just the image and the target is the label of the image. So for a simple case, it could be either cat or dog. And then our machine learning model gets the features, so the image, as an input, and then from that it has to predict the label. And to perform this prediction, the model has parameters. And so based on these parameters and the features, the model calculates the target or label. And what happens then if the model is off is that the parameters are adjusted based on how wrong the prediction is. And through that, the model then learns to adjust its parameters, and eventually it will get better and better at predicting which features should be a cat or which features should be a dog. And so the model is classifying our data. The other part of supervised learning is regression. And here we're doing almost the same thing. So we have some features, and from these features we're trying to predict a target. So for example, here for weather forecasting, the features might be the weather 2 days ago, and the target would be the weather today. And now the difference is that we're not predicting a label, but we're predicting a number. So for example, for weather forecasting, we could predict the temperature, air pressure, or humidity. And of course, we can also turn most regression problems also into a classification problem by, for example, saying that a certain temperature and humidity corresponds to good or bad weather. And in reverse, it's also often true that when we classify an image, the model actually predicts numbers. So you can imagine from 0 to 1, and if the number is bigger than 0.5, then it's predicting a dog, and if it's lower, then it would predict a cat. And to give some short explanation, in this case here, what the model does is essentially matrix multiplication and then applying functions that have a derivative. And through these operations, we're not guaranteed to get integer numbers. So our output will not be 0 or 1 corresponding to the classes, but we'll deal with continuous values, maybe from 0 to 1. Before we jump into the code, some quick information on the other fields. Part of unsupervised learning are also generative networks, and here we try to model our data and then from the model generate similar data. So you can imagine we feed our model a bunch of cats and dogs, and then we can generate new cats and dogs from that model. Another part is dimension reduction, and this also relates to the clustering. So here we imagined 100 dimensions and ended up with only 2. And so this also happens here, except for the fact that we're not adding this cluster structure on top. And so for example, this can be useful to visualize big data, which is generally very high dimensional, or we can also extract features from our data. And this can be also paired with classification, so that our model doesn't get all the pixel values, but maybe just a few features that help it identify the difference between cats and dogs, which would make our process more efficient. For now, we'll skip semi-supervised learning and reinforcement learning, but if you're interested, we could provide you with some resources.